Hello everyone, I'm Paul and today we're solving problem 3363, find the maximum number of fruits collected. I will say this one is reasonably hard, so here I will show you how to solve this step by step. This is a nice description, you can read this if you want, but basically we are given a grid such as this one, where each cell represents a room in a dungeon with some amount of fruits. And there are three children here. We have one here in the top left corner, one is here in the top right corner, and the last one is here in the bottom left corner. And each of these children need to reach this bottom right corner. Every child grabs every fruit from each room they step into. The goal is here. We need to return the maximum number of fruits the children can collect. And the key observation for this problem is here. Each child has to move exactly n-1 steps. So with this in mind, let's start with this child. We know we need to reach this point in exactly n-1 steps. Here n is 4, so n-1 is 3. This means we have only one possible path from here. We can move here, then here, and then here. This is the only possible way in which we can reach from here to here in exactly 3 steps. And we need to collect every fruit on the way, so the result will be initially 1 plus 6 is 7, plus 11 is 18, plus 16 is 34. So we can forget about this child and we have already collected every fruit on this path. Now let's continue with this child. We need to go from here to here in exactly 3 steps. And what this means is we will never visit this cell, for example. Because if we go from here to here, we are already using 2 steps. And from here to here, we have at least 2 more steps, and that's 4 in total. But we need to take exactly 3 steps. So we have 2 possible ways in this case to go from here to here in 3 steps. One is to go first here, and then here, and then here. And the sum in this case is 4 plus 8 plus 12. And that's it, because we have already collected the fruits in this room. So the sum in this case is 24. We have a second possibility, which is to go from here to here, then here, and then here. And in this path we have 4 plus 7 plus 12. And this is 23. And the maximum among 24 and 23 is 24, so we add to the result 24. Meaning we have already collected these fruits. And finally we are here and we do the same. We have 2 possible paths. One is to go first here, then here, and then here. And the result for this path is 13 plus 10, 23 plus 15, 38. And the second possibility is to go here, then here, and then here. And in this path we have 15 plus 14 is 29 plus 13 is 42. And 42 is greater than 38, so we keep 42 and we add these to the result. And 34 plus 24 plus 42 is 100, so we return 100. Now, in case you didn't notice, this is a perfect problem for dynamic programming. Why? Well, because we are keeping track of previous states, previous counts at each room. So now I will show you how this works. First, we know we can start with this child and take the sum for this diagonal, which is the only available path for this child. So the result is currently 34. And now we have a DP grid with the same size, and every element in this grid is initially 0. So first we are adding this to the same position in our DP, so we have a 4 here. So now we continue with these children, and first we are adding this value in the same position in this new grid. So we add the 4 here. And what this 4 represents is if we had to start here and end here, meaning if our grid was only this, the maximum we could collect with this child would be 4. And now remember what are our possible paths. This is one possible path and this is another possible path. So we see a pattern here. This is a triangle. So we are iterating every cell in this triangle. And we already have a 4 in our DP. So actually we are just iterating every element except for this 4. And this is how we can iterate these elements in code. We go from row 1 to row -1, -1. Remember, this is not included, so we go up to here. And for columns, we say the lower bound is the maximum among I plus 1. Remember, we are not visiting this side. So we take the maximum among I plus 1 and n minus 1 minus I. This is how we can get the shape of a triangle. And the right bound is n. And each time we do the following, let's say we are here and we need to fill this value in our DP. And remember, what this represents is the maximum fruits we can collect if we end our path here. So we are taking the maximum among these 3 elements. Remember, every empty cell is 0. So the maximum here is 4. And we are adding these 8 fruits. And 8 plus 4 is 12. So we put 12 here. And now we are here and we do the same. If we are here, we could come from any of these 3 cells. So the maximum among these 3 elements, this is out of bounds, of course. So the maximum here is 4. And 4 plus 7 is 11. So we put 11 here. And remember, we are iterating this triangle except for these first 4. So next we are here. And if we are here, we need to look at these 3 cells. Remember, this is out of bounds. So the maximum among 12 and 11 is 12. So we do 12 plus 12. And this is 24. And we end here because remember, these fruits are already taken. So we add 24 to the result. So this is the last child and we have 2 options. We can repeat the same we did here, but this requires a lot of code, or we can use the same, exactly the same we did here after transposing this grid. In case you don't know what transposing is, it's as if we had a mirror for this grid. So 13 is now here, 4 is now here. This diagonal is exactly the same as this diagonal. And for example, here we have 2, 5, and here we have 5, 2, and so on. So this is the transposed version of this grid. And this is the magic. We can use the exact same code we used for the DP for this child here. And we are iterating this same triangle, but now it's as if we were iterating this triangle. So we will run the same DP here, starting from top right again. So this is a new DP grid with all zeros, and here we are using this value, the starting point. So this is 13 initially. And now we are iterating every other element in our triangle. So we start with 8, meaning we are here. And the maximum among these 3 elements, remember this is 0 and this is 0, the maximum is 13. So 13 plus 8 is 21. Next we are here, meaning in this cell. And the maximum among these 3 elements, this is out of bounds, is 13. So we do 13 plus 14, which is 27. And finally we are here. And from this cell, we take the maximum among these 3 elements, meaning 27, plus 15. And this is 42. And we reach the end here, so we add this 42 to the result. and 34 plus 24 plus 42 is 100. So we return this. Time and space complexity for this approach will be big O of n squared. So now let's go with the code, and hopefully you will get the idea. First we say n is the length of fruits, and first we start with the child from the top left, so the result is initially the sum for the diagonal. So here we say fruits I for I in range n. And now we can build our dp function. Remember, we are using this function 2 times for remaining children. And first we have an empty grid here. So this is an array with 0 times n for every index in range n. And the first value, grid 0 n minus 1, the first value in the top right corner will be fruits 0 n minus 1. And now we can iterate this and fill our dp. So for I in range from 1 to n minus 1, and for j in range from the maximum among I plus 1 and n minus 1 minus I. Remember, we are iterating this in the shape of a triangle, and this is the maximum value among this, and this is the left bound, and we will go all the way up to n minus 1. Remember, this is not included. And in here we need to take the maximum value from the upper row, from the 3 adjacent values in the upper row. So we do best equals grid I minus 1 j, and now best is the maximum among best, and grid I minus 1 j minus 1, and if j is smaller than n minus 1, we say best is the maximum among best, and grid I minus 1 j plus 1. And finally we need to update the current value in our dp grid. So grid I j is best plus fruits I j. And finally we can return grid at n minus 2, n minus 1. So now we can run this function for the child in the top right corner. So we do result plus equal dp, and now we can transpose our fruits grid. And remember the drawing a few seconds ago, we can do for I in range n and for j in range I. So we are iterating every column up to I, and each time we are doing fruits I j, fruits j I, and we need to swap these two values. So this is equal to fruits j I, fruits I j. And finally we can run the same function again. We add to the result a call to dp, and now we are adding the path for the last child, and finally we return the result. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So If you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.